Today, let's talk about groundwater. If you have seen one of our previous videos for moisture in soil, we saw there how water sits in tiny spaces between the soil particles. Today, we'll dig a little deeper, literally. We will uncover water table and groundwater. We'll talk about infiltration and aquifers and see why they all matter. Do you know about water table? The line that really matters. Let's try to see this through my average drawing skills. If you keep digging near a water body or in a moist soil, we reach to a point where all soil gaps and soil cracks are full of water. In reality, it would look something like this. The top surface of this zone, where gaps and sacs are starting to be full of water, is what we call water table. Now, many think water table is equal to groundwater. That's not true. Water table is just the line on the top that you see here in a straight horizontal way. That's what we call water table. All the water below it is what we refer to collectively as groundwater. So how is this groundwater formed? The water inside the soil must be coming from outside and getting stored there, right? Now this is mainly happening through two ways. Rainwater that sips in the soil recharges the groundwater instantly, as we all know it. Second way is rivers or ponds or water bodies, they keep it charged. However, particularly when they overflow during peak monsoon season or due to some reason or another, when these water bodies overflow, they help significantly in recharging the groundwater more. Collectively, rainwater and this overflow of water bodies, they cause the seepage of water in the soil, or there is a term for it that we call infiltration. So we have a formula here. Infiltration is the way groundwater gets recharged. Now let's go a bit deeper. Sometimes groundwater collects in the layers of rock or loose material that can hold and pass the water. These natural underground stores are what we call aquifers. We can use these aquifers, even they are foots or meters inside the soil, using hand pumps or tube wells. You would have seen these tube wells in the villages or even hand pumps during one of your treks in the mountains. All of that water comes from such little or big aquifers. But why does groundwater matter? Well, groundwater acts as a support system for lives that are present in those regions. It supports life in many ways, like farming, where it is used in the irrigation for crops. Second and super important use of groundwater is as drinking water, particularly for villages and towns where large water bodies are not present. Thirdly, it is super important for soil health. Groundwater keeps the soil moist and fertile. Moisture of the soil and the fertility of the soil impacts hugely to the life present and dependent on the soil. And fourth, groundwater impacts the ecosystem of the region, where trees, plants and animals that are dependent on it, how they interact with groundwater, how they use the groundwater, etc. So, what did we learn? We learned that water table is the top line of the underground water, and groundwater is the water below that line. We also saw that infiltration is the way through rain or river water seep down in the soil, and that way the groundwater is recharged. We also talked about aquifers, how they are rock or soil layers storing the water, and they can be tapped by pumps or tube wells. And why does groundwater matter? Because it is important for farming, drinking, soil and ecosystems. Now you can imagine that groundwater recharge is a very slow process and it's dependent on multiple factors. Can we keep drawing groundwater endlessly? What if we use more than nature can recharge? That's our next video, depletion of water. Stay tuned for that video as well. Keep learning science. Have fun. Thank you.